Hi, my name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury, and this video shows calculus students how to work the quotient rule. Students think of the quotient rule as something that's difficult, and it is a little more difficult than the product rule, for example. However, you'll see that it's exaggerated, the difficulty. It's actually pretty easy to work, and with a little practice you can have it down in no time. So let me first start by actually showing you what the quotient rule is. And so we start with a function f of x, let's say, over g of x. And if we want to differentiate this function, we're going to take the derivative of the numerator, which is f prime x, and we're going to multiply it by the denominator. And then we're going to subtract off the derivative of the denominator, and we're going to multiply that by the numerator, and then we're going to divide this whole thing by the denominator squared. Now, one of my students, she came up with a really nifty way to rewrite this. She says, well, it's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator divided by the denominator squared. And that's how she writes it. And it works for her, and I think it'll probably work for you. It's a great way to notate the quotient rule. So, okay, let's move on to an actual problem and put it into practice. So here's a function, y equals 3x minus 1 divided by 2x plus 1. And let's differentiate this thing. So y prime, the derivative, well, it's the derivative of the numerator, which is 3, times the denominator, which is 2x plus 1, minus the derivative of the denominator, which is 2, times the numerator. And we're going to divide this whole thing by the denominator squared. Okay, well, now it's just a little bit of junior high school algebra. Y prime is equal to 6x plus 3. We're distributing the minus sign with this. Don't forget to do that. Minus 6x, oops, plus 2 divided by 2x plus 1 squared. And now, well, we can pretty much finish it up here. The positive 6x and the minus 6x go out, so we're left with 5 divided by 2x plus 1 squared. And there's our derivative. So it was an easy little quotient to differentiate, but relatively easy, I think, and painless. Let's take a look at another problem. F of x equals 2x divided by 4 plus x squared. And let's differentiate this one. So f prime x, well, we're taking the derivative of the numerator, which is 2, times the denominator, 4 plus x squared. And we're going to subtract off the derivative of the denominator, which is 2x, times the numerator, which is 2x. And we'll divide this whole thing by the denominator squared. Okay, well, let's move on to the next step. F prime of x. Let's distribute the 2 here and the 2x here. Well, this is just a straight multiplication. 8 plus 2x squared minus 4x squared divided by 4 plus x squared squared. Okay, we should be able to finish it up right here. We have 8 plus, well, 2x squared minus 4x squared is minus 2x squared divided by 4 plus x squared squared. So this one's finished. That takes care of this derivative. Let's move on to the next one. We've got g of x is equal to x cubed minus divided by 1 minus x squared. So let's get right to work. We've got g prime of x is equal to, well, the derivative of the numerator is 3x squared. And we'll multiply it by the denominator, 1 minus x squared. And subtract off the derivative of the denominator. Well, the derivative of the denominator, we have this minus sign here, so it's going to be negative 2x. Let's do this. Put a square bracket in here. Negative 2x times the numerator, which is x cubed. Okay. Over the denominator squared. And let's move on. Okay, it's just algebra from here, and that's often the case with these calculus problems. The difficult part with calculus is not the calculus rules. They're relatively easy. It's the algebraic workouts. Okay, 3x squared times 1 is 3x squared. 3x squared times minus x squared is minus 3x to the 4th. And then, I think I'm just going to burn an extra step here. Minus negative 2x times x cubed is negative 2x to the 4th. Divided by 1 minus x squared squared. Alright, let's move on. So we have 3x squared minus 3x to the 4th plus 2x to the 4th divided by 1 minus x squared squared. And let's see, I think we can finish it up here. G prime of x, let's see, we've got 3x squared minus 3x to the 4th plus 2x to the 4th is minus x to the 4th divided by 1 minus x squared squared. Okay, so that's it. We're not going to be able to go any further with this particular derivative. So, well, actually, let me just do this. Let me take another piece of paper. Let me just show you something. If we wanted, we could just clean it up a tad. We have here, so g prime of x is equal to, we could factor out an x squared from the numerator if we wanted to. X squared times 3 minus x squared divided by 1 minus x squared squared. So we could, take it to here if we wanted to. It doesn't add anything to the problem. In other words, it's nice, we can factor out the x squared, but, big deal. It didn't advance the cause at all. So, let's leave it. Either way is perfectly acceptable, I think. Okay. What have we got now? We have y equals x cubed minus 2x times the square root of x divided by x. So, actually, there's a couple different ways we can handle this. I think the easiest way to do this is let's just get rid of the denominator. The denominator goes into this x cubed and into this 2x. So we can actually rewrite this. And you should always be looking for opportunities to take the quotient and turn it into a product rule or just a power rule problem. And that's what's going on here. So y, boy, I am running out of ink here. Y is equal to, well, x goes into x cubed. We can make that x squared times minus x goes into x once, so it becomes 2 square root of x. So now this is just a simple little power rule problem. We are going to rewrite x. The square root of x is x to the 1/2. Let me do that now. X squared minus 2x to the 1/2. So now y prime is 2x, right? The derivative of x squared is 2x minus, well, and here we're going to take a half and multiply it by 2, and that's 1. And I'll just put it out here for now. Times x, and we're going to subtract 1 from the half, and remember that 1 equals 2 over 2, so 1 over 2 minus 2 over 2 is negative 1 over 2. So this becomes negative 1/2. So y prime is equal to 2x minus, minus x to the negative 1/2. And let's just kick this down into the denominator. Y prime equals 2x minus 1 over the square root of x. Now, ordinarily, I would say, this is the derivative, okay? But we can do something. We can rationalize this particular fraction, okay? It's bad form typically to leave the square root in the denominator. So let's kick this square root up into the numerator. So in order to do that, and let me do it this way. We have y prime equals 2x minus, and it's 1 over the square root of x. So let's multiply by a very special form of 1. We'll multiply by the square root of x over the square root of x. So y prime is equal to 2x minus the square root of x over x. So this is called rationalizing the denominator. And if we wanted to, we could also bring this all into one fraction. So we could also do this. Y prime is equal to, well, we now have a denominator of x, so let's multiply 2x by x over x, which is also equal to 1. And we get y prime is equal to 2x squared over x minus the square root of x over x. And we can now combine the numerators over the one common denominator. So y prime is equal to 2x squared minus the square root of x over x. So if you wanted to, this is another way that we can write the derivative that we had up here. So we had, let's fold this over. Here was the original derivative that we got for this problem. It can be rewritten into this form, as you just saw. And either way is perfectly acceptable, I'm sure. You should probably check with your professor to make sure that this is all right, that you can leave the square root in the denominator. If you can't, then you're going to need to rationalize the denominator, and you just saw again how to do that. So, okay, let's end this video with this particular problem. The second video will pick up where this left off, and the videos on the quotient will become progressively more difficult as I move on. There will probably be 3 or 4 in total, including a couple where I just use trig functions in the quotient rule. So once again, this is Charles Kaplan. I wish you all good health, happiness, long lives, and a lot of good luck along the way. Bye-bye.